Hello and welcome to the fifth part of our course Introduction to Communication Engineering. In this part, we will start talking about digital signals. So far, our discussion on communication has been confined to analog signals only. We have talked about amplitude modulation, frequency modulation, and also phase modulation. All those modulation schemes were applicable for analog signals. From this point, we will start talking about digital signals, how to convert an analog signal to digital signal, and also how to transmit digital signals. So in this lecture, or in this part of the course, we will talk about converting an analog signal to a digital signal. And in the next part, which will probably be the last part of this course, in that part we will talk about how to transmit digital signals via communication channel. Now, without any further ado, let's get started. So, as I've said, this is the fifth part, and the module name is pulse code modulation. So, let's dive in. So, basically, in the pulse code modulation scheme, we will convert an analog signal to a digital signal. There are several stages of this conversion. We will talk about each of these stages gradually. First of all, let's take an overall view of what a PCM system looks like. So, here is the transmitter side. In the transmitter side, we have the source of continuous time message signal. One thing to note here is, whatever we speak is actually an analog signal. So, obviously, the source of the message must be an analog signal unless it is generated by computer. If it is generated by computer, then it is a digital signal, but otherwise, if this is a human speech, then it must be an analog signal. Okay, so at first we pass it through a low pass filter. This low pass filter is also known as anti-aliasing filter. We will know about this low pass filter detail in the later section. So the output of this low pass filter is then fed to the sampler. The sampler basically samples the continuous signal. So a continuous signal is basically continuous in both time and amplitude. We can have every value of time in a continuous signal, and also amplitude can be any value between a certain range. So what sampler does is, sampler makes the continuous signal a discrete time signal. That means after passing through the sampler, the signal is no longer continuous in time domain, but it is still continuous in amplitude domain. Or for better view, when we draw a signal, there are two axes. One is x-axis. In x-axis, we set the time, and in y-axis, we set the amplitude. A continuous signal is continuous in both time or x-axis and amplitude or y-axis. But when we pass that signal to the sampler, the signal is no more continuous in x-axis or in time domain, but it is still continuous in the amplitude or y-axis. So after passing through the sampler, it's now discrete time signal. We call it discrete time signal because it is discrete in time. Then when we pass this discrete time signal through a quantizer, it is further discretized in y-axis or amplitude. So in the sampler, it's discretized in time domain or x-axis. And after the quantizer, it is discretized in both x and y axis, which means it is now discrete in both time domain and amplitude domain. Okay, so after discretizing, we have to encode the signal. So encoder block is used for simply encoding the signal, and it is ready for passing. And this output of the encoder is known as PCM data sequence. We pass this data sequence to the communication channel. There are different ways to transmit this data sequence. We will talk about the transmitting techniques in the later portion of this course. For now on, we will focus more on this transmitter part. So there are basically three basic operations in a PCM transmitter. They are sampling, quantization, and encoding. We will talk about each of these parts individually in great depth. And the reverse of these operations are done in the receiver, of course. So if we know about the transmitter operations in detail, it will help us develop an insight about the receiver portion also. So the basic block diagram is a continuous signal is transferred into a Pcn data sequence. That Pcn data sequence is then transmitted to the transmission line, you can see, and when it is received again, the Pcn data sequence is again converted to the original continuous signal in the receiver.